So, you know about that math project?
Yeah.
I got an idea. We can do puppets.
Oh my god, let's... No, absolutely not.
No. Just look. Come on. Like this and like this and...
No.
Okay, here. You can be this one and I'll be this one.
This was a great idea.
As you very well may know, scaling things up is very difficult.
Very difficult.
Just take this picture for example.
When small, it is cute and fluffy, but as we enlarge it, it becomes pixelated and ugly.
Imagine you're working at Panda Express for only a few hours a day, yet you receive the full healthcare package right away.
This is the case for most of Hawaii, and although other living expenses are quite costly, even waiters at small cafes can get loads of health benefits due to state laws.
That's one of the reasons why U.S. Hawaiian citizens live longer on average than their mainland counterparts. But should our senators really implement this successful Hawaiian healthcare system on a national level?
Well, the answer is no, because a system that works for 1.4 million people is probably not going to work so well for a population almost 300 times its size because of high cost and difficulty of regulation.
As you can see, extensive application of something so minuscule, no matter how effective, is not always the greatest solution for a widespread problem. On a more natural note, biodiversity scales up with an increase in limited resources such as food or water, but only up to a certain point.
Then it reaches what is called the carrying capacity. From there, limiting resources are often not sustainable in large amounts, so neither is a scaled-up population, which will often die back into something more manageable.
A similar situation occurs with weight. If a 6-foot tall person weighing 150 pounds magically grew to be 36 feet tall, then his weight would actually increase by a factor of 6 cubed, which means that his weight would go from 150 pounds to 150 times 216, which would be a whopping 32,400 pounds.
Then, since the cross-sectional area of his legs would only vary with the factor of his height squared, his legs would no longer be able to support his body weight, his massive body weight, and he would no longer be able to walk.
The prime instance where individual preferences are not represented in a group's preferences is in voting. This is called Arrow's theorem, which is also known as the voter's paradox.
Suppose that there are 100 senators, 33 Russells, 33 Anitas, 33 Pranavs, and the one and only Miss Spear, and each named group votes the same. Each of them is presented with 3 proposals, A, B, and C, for nationwide fudge quality standards, and are asked to rank them from 1 to 3, with 1 as the most appealing and 3 as the least.
According to the chart, Miss Spear chooses not to vote, because she has higher standards for fudge than all of the other senators combined. But the Russells and Anitas prefer Proposal A over Proposal B, and all Russells and Pranavs choose Proposal B over Proposal C.
So it makes sense that since Proposal A is preferred over B, and B is preferred over C, then A should be preferred over C, right?
However, when C is compared with A, it appears that all the Pranavs and all the Anitas prefer standard C over A. Therein lies the paradox.
While it seems that this is a result of an irrational group of senators, this is just because of the way the voting works. Majority voting often fails to give consistent response that accurately show how a group as a whole feels about a certain issue.
It all depends on the perspective you choose.
All of this leads back to one conclusion.
Scaling things up is so difficult to do.
There's hydrogen and helium and lithium, beryllium, boron, carbon everywhere, nitrogen all through the air, and oxygen so you can breathe, and fluorine for your...
Okay.
What are you doing?
Oh, you're recording.
Yay!